This is Algebra 2 lesson 3-5. Graphs in 3 dimensions and systems with 3 variables. Coordinate space is adding a third axis, otherwise known as the z-axis, to the xy coordinate system, which now means you can graph in 3 dimensions. You can graph left and right, up and down, front to back. Ordered triples in the form of x, y, z represent the points graphed in coordinate space. Let's learn how to graph points in 3 dimensions. Right, let's look at graphing in 2 dimensions, and we'll compare that to graphing in 3 dimensions. If you have an x and y axis, as I simply do in this particular first picture here, my x-axis is my horizontal axis, and my y-axis is my vertical axis. If I was going to plot a point 2, 3, I would start at my origin, go right 2 units, up 3 units, and there's my plotted point. In space, a 3-dimensional point, say the point 2, 3, 4, says that I would start at my origin, which is still in the middle here, but now my x-axis, if you notice, here's my x-axis, my y-axis is here, and my z-axis is here. So the x-axis is front to back, my y-axis is left and right, and my z-axis is up and down. Okay? So when I'm going to plot the point 2, 3, 4, the first thing I would do is I would start at the origin, and I would go forward 2 units. There's forward 2 units. Then I'd go to the right 3 units. There's 1 unit, 2 units, 3 units. And then I would go up 4 units. 1 unit, 2 units, 3 units, 4 units. Okay? Up 4 units, 1, 2, 3, 4. Okay. Kind of interesting to do. It's a little bit easier if your 3-dimensional graph paper actually has the 3-dimensional points, which when you need to graph, I will provide you a 3-dimensional graph paper that actually has all the lines to it. So that kind of walks you through how to graph something in 3-dimensional space. Okay, let's practice a couple more. Let's sketch the point of 0, 3, negative 2. Okay, so if I'm going to start here, I'm going to go 0 on the x-axis. I'm going to go 3 units to the right on the y-axis, and I'm going to go down 3 units on the z-axis, and my point ends up to be there. Okay. For the point negative 2, negative 1, 3, again, start at the origin. Negative goes backwards, so we're going back 2. Negative 1 goes left 1, and then positive 3 goes up 3, and there's our point right there. Okay. Kind of interesting to do. It's not really complicated, but it is kind of important. Now, the graph of an equation is a picture of all 3 solutions to that equation. In 2 dimensions, the graph of 3x minus 2y equals 6 is a line. In 3 dimensions, the graph of 3x minus 2y plus z equals 6 is a plane. What you end up doing is you end up graphing intercepts for all of these, and then you connect those intercepts. They call these traces. You'll get what's called a YZ trace, like right here, this YZ trace right here, is because you graph the intersection of y to z, okay, there's y to z right there, and you graph the intersection of y to x, and that's a YZ trace. The wording is not all that complicated. I wouldn't get all hung up on it because that's confusing. All right, now, the x-intercept of a line or a plane is the point of intersection of the x-axis. If the graph of a plane intersects one of the coordinate planes of a line, then the line is called a trace. That's what we're going to trace. For example, an xy trace is the line in the xy plane that contains the x and y intercepts. The xz trace and the yz trace are defined similarly. All right, we're going to sketch a plane, find the x, y, and z intercepts, and draw the traces and show the plane with the shape. So it's not all that hard. So we're going to sketch the point. 2x plus 3y plus 4z equals 12. The first thing we're going to do is find all your intercepts. To find the x-intercept, solve for x, everything else becomes y that has a variable with it. So to find the x-intercept, substitute in 0 for y and z. Okay, so that's simply what we did. So we had 2x plus 3 times 0 plus 4 times 0. So 2x equals 12, so x equals 6. That's important right there. To find the y-intercept, substitute in 0 for x and z. So you get 0 plus 3y plus 0 equals 12, or 3y equals 12, which means y equals 4. And last but not least, to find the z-intercept, substituting 0 for x and y. So you're going to get 4z equals 12, so z is 3. So those are our 3 points, 6, 4, 3. That's important. 6, 4, 3 is the points that we have to figure out how to graph. Okay? If they're the intercepts, so if these are our intercepts, then the x-intercept, so if you're doing the x-intercept, let's go back up here so we can actually see what the x-intercept is. The x-intercept is 6. So we're basically going to have 3 points here. We're going to have the point where the x-intercept is 6. So that's going to be the point 6, 0, 0, because the y and z-intercept are 0. The y-intercept is 4, you're going to have 0, 4, 0. And the z-intercept is 3, so you're going to have 0, 0, 3. So these are the 3 points to which you need to plot on your graph paper. So we have to plot the point 6, 0, 0. So we're going to go here and start at the origin, go up 6, 1, 2, 3, 4, 5. So 6 would be about there. Okay, so there's 6, 0, 0. There's the point 6, 0, 0. Then I have to plot the point 0, 4, 0. So 0 on the x, 4 on the y. 1, 2, 3, 4, 0 on the z. So there's 0, 4, 0. And last but not least, we're going to plot the point 0, 0, 3, which is 0 on the x, 0 on the y, 3 on the z, 1, 2, 3. So this is 0, 0, 3. So we've plotted those 3 points. Now we need to draw the traces, which means basically draw the lines that intersect these 3 lines. So if I was going to draw these 3 lines, okay, I'm going to do this line here. And then we're going to do this line here. There's my second trace, lock it in place because and last but not least, I need my last trace, which would be between these 2 points up here. Here, this point here. And lock those in place. And we shade between, the region between all of those is where we shade. So I'm going to shade the region between these with some sort of yellow color. And that would be the solution to this in 3 dimensions. Okay, that's each point on the plane would represent the solution to 2x plus 3y plus 4z equals 12. There you have it. So that's not too terribly bad. That's graphing in 3 dimensions. Now, let's solve a system in 3 dimensions. A little bit harder. Okay? To solve a system of 3 equations and 3 variables, you can use some of the same algebraic methods that we use to solve systems with 2 equations and 2 variables. Okay? Probably the easiest method is to use the elimination method. Now we have 3 equations here. I'm just going to number them 1, 2, and 3. The point here that we need to do is we need to take any 2 equations and eliminate a variable. Once you've eliminated that variable, you need to take 2 different equations but eliminate the exact same variable. For example, I'm going to take equation 1 and 3. Equation 1 is negative 5x plus 3y plus 2z equals 11, and equation 3 is 4x minus 7y minus 2z equals negative 29. I chose those 2 because notice what happens to z if I choose equation 1 and 3 and I add them together. My z's will be eliminated. If I add these together, I get negative x minus 4y equals negative 29 minus 11 is negative 18. So So this becomes equation number 4. Very important to number your equations so you don't get confused. Okay, now I'm going to take equation 2 and equation 3, and I'm going to add them together because I'll again eliminate z. I need to take two different equations, but eliminate the exact same variable. So I'm going to take equation number 2. Equation number 2 says 8x minus 5y plus 2z equals negative 55. Equation number 3 says 4x minus 7y minus 2z equals negative 29. We need to add those together. 8 and 4 is 12. So 12x, 7, 5 is 12. So minus 12y equals negative 55 and negative 29. 25 is 14, so 4. This becomes equation number 5. Now I'm going to take equation number 4 and equation number 5, and I'm going to either eliminate x or y. Okay, I'm thinking eliminating x might be fairly simple because all I have to do is multiply first equation, let's just take equation number 4, which is negative x minus 4y equals 18. And equation number 5, which is 12x minus 12y equals negative 4. I'm going to take equation number 4, and I'm going to multiply it by 12. That gives me negative 12x. Okay, 4 times 12, negative 12. It was positive 48. Negative 48 minus 48y equals negative 18 times positive 12 is negative 216. I'm just going to take this fifth equation just as it is, 12x minus 12y equals negative 84. And I will get, my x's will cancel out, 48 plus 12 is 60y, and 216 and 84 is going to be negative 300. Divide negative 300 by negative 60, and you're going to get y equals 5. So there we have our first variable solution, y equals 5. Now that I know that y equals 5, I can go back into equation 4 or equation 5 and solve for x. I'm going to go into equation number 4 because it seems like it has smaller numbers. So I'm going to have negative x minus 4 times 5 equals negative 18. So negative x minus 20 equals negative 18. Add 20, add 20. Negative x equals 2. That means x equals negative 2. So I now know that x equals negative 2, y equals 5. So to find z, I can plug into either my original equations to 1, 2, or 3, and it doesn't matter which one. I'm just going to choose 1 because it's easy, it's there. So I'm just going to put in negative 5 times negative 2 plus 3 times 5 plus 2z equals 11. So 10 plus 15 plus 2z equals 11. So 25 plus 2z equals 11. So I subtract 25. So 2z equals 25 minus 11 is 14. So 2z equals 14, which means z equals 7. So my solution to this inequality, written in x, y, z form, is negative 2, 5, and then 7. And of course, you could check these. They have to fit all 3 equations simultaneously to be a true equation. Oops, should be negative 14, should be negative 7. And it's not 7. Alright, so negative 2, positive 5, and negative 7. Now those can be a little bit time consuming, but they are necessary in understanding how to do this. You can also use substitution. Substitution is the best method to use when one of the variables can be easily solved for another. If we look at this one, 12x plus 7y plus y is equals 16, 2x plus y minus 14 is equals negative 9, negative 3x minus 2y plus 9 is equals negative 12. If I looked at this equation number 2, seems the most feasible here, because I can already solve it for y. I wanted to solve this equation for y, y would equal 2x plus 14z minus 9. And there it is, in back down. Now, I look at that, I can substitute that into equation 1. So if I took that and substituted it into equation 1 says 12x plus 7 times y, which is now 2x plus 14z minus 9 plus 5z equals 16. So I'm now just going to substitute in. So 12x plus 14x plus 14 times 7 is 98, 98, z minus 9 times 7 is 16. 3 plus 5, z equals 16. Let's simplify. That becomes 26x. 98 and 5 becomes 103. And then I move my 63 over, so that's going to equal 79. This guy over there. So this becomes equation number 4. Now I'm going to do the same thing, except for I'm going to substitute it into equation 3 now, and do the same thing and get it so that I have an x and z left over. So in equation number 3, I have negative 3x minus 2 times y, which is 2x plus 14z minus 9, plus 9z equals 12. So we will get negative 3x minus 4x minus 28z plus 15 plus 9z equals negative 12. Combine my terms. That will give us negative 7x, negative 28 and 9 is going to give us negative 19z. And if I move my 18 to the other side, I'm going to subtract it, add those together, it's going to be negative 13. So that gives me equation number 5. I now have two equations with two unknowns. I now need to eliminate either x or z. Both of these are really, really large numbers. Okay. So I have 26x plus 103 equals 79. That's equation number 4. And you can look at that up here. 26x plus 103z equals 79. Equation number 5 is negative 7x minus 19z equals negative 30. I have to eliminate something. I'm thinking it's probably easiest to eliminate x. So I'll multiply this top equation by 7 and this bottom equation by 26. I'm not going to try to find a comment on it. Just multiply them both by the opposites because it's easy. 7 times 26 is 182. 182x. 7 times 103 is 721. 721z. And 79 times 7, I'm going to do this down here so you can actually see it a little better. Let's squeeze it in there. So 182x plus 721z equals 79 times 7 is 553. All right, 26 times negative 7 is a negative 182x. 26 times 19 is 494z. And negative 30 times 26 is negative 718. This is new equation 4, this is new equation 5. If we add them together, these will cancel out. 721 minus 494 is 227z. Equals 553 minus 780 is negative 227. Hey, what do you know? Z is going to equal negative 1. So now that z equals negative 1, I can plug it back into equation 4 or equation 5 to figure out what x equals, and then I can figure out what y. So let's go back to equation number 4, which is 4 I multiplied by 7. So equation number 4 says 26x plus 103z equals 79. So 26x minus 103 equals 79. So add 103. 26x is going to equal 182. 526. X equals 7. Now when x equals 7, z equals -1. I'm going to go way back up here to my original where I said y equals 2x plus 14z minus 9. So let's go with that. Y equals 2x minus 14z plus 14z. Right? 2x plus 14z minus 9. So y equals 2 times x, which is 7, plus 14 times -1 minus 9. So y equals 14 minus 14 minus 9. So y equals -9. So our ordered triple for this one is 7, -9, and -1. As you can see, these take a lot of time. If you mess up one small step, it will mess up pretty much just about everything. So you have to be very, very careful. One last one. Let's look at a word problem. You are an office supply distributor and you budget $7,200 for 80 office chairs. You can buy leather chairs for $125 each, mesh chairs for $100 each, fabric chairs for $75 each. You want to have 3 times as many fabric chairs as leather chairs. How many of each type should you buy? Okay, let's make this easy. X equals leather. Y equals mesh. And Z equals fabric. I could have used L, M, and F, but my L's look a lot like 1s, and I wouldn't have messed it up. You can buy at most 80 office chairs. So one of my equations has to be based upon the number of chairs that I buy. So the number of leather chairs plus the number of mesh chairs plus the number of fabric chairs has got to equal 8. One of them is going to be based upon the price of the chairs. Leather chairs are $125 each, so 125x, plus mesh chairs are $100 each, Y, and fabric chairs are $75 each, 25Z, and that's going to be my total budget of $7,200. So here's my second equation. There's one equation, there's 2 equations. Third equation says if you want to have 3 times as many fabric chairs as leather chairs. So fabric equals 3 times as many leather chairs, so 3x has to equal z. That's my third equation. 3x equals z. That gives me 3 times as many fabric chairs as leather chairs. However many leather chairs I have, I multiply that by 3. That gives me my fabric chairs. This actually makes our equation a little bit easier because we now know that z equals 3x. So we already have it solved for a variable. Okay? So, if I was to look at this, equation 1, x plus y plus z, which is 3x, equals 80. I'm just going to take equation 1 right now, and I'm going to plug in equation 3 into equation 1. So I have x plus y plus z is 3x, 3x is 8. So by doing that, I now have 4x plus y equals 8. There's equation 4. And I can do the same thing with equation number 2. I'm going to plug in equation number 2. I'm going to do the same thing. I'm going to plug in, over here, side a little bit. Equation number 2, I'm going to have 125x plus 100y plus 75z, but 75z. Z is 3x equals 7,200. So now I'm going to have 125x plus 100y plus 75 times 3 is 225. 225x equals 7,200. So 125 plus 225 is 350, so 350x plus 100y equals 7,200. This is equation number 5. Now I can take equation number 4 and equation number 5, and you either eliminate x or eliminate y. Equation 4 is 4x plus y equals 80. Equation 5 is 350x plus 100y equals 7,200. So it seems wise to me to take equation 4 and multiply by a negative 100. That would give me negative 400x minus 100y equals negative 8,000. And then I have 350x plus 100y equals 7,200. So, negative 50x equals negative 800, which means x equals 16. So x equals 16, z then, e times 16, x equals 3z, z equals 3x. So z is going to equal 48. And last but not least, plug it into equation 1. X is equal to 16, so 16 plus y plus 48 has got to equal 80. 48 and 16 is 64, so y plus 64 equals 80. Subtract 64 from 80, y equals 16. So, you need to buy 16 leather chairs, 16 mesh chairs, and 48 fabric chairs. There you have wrapping in 3 dimensions and solving an equation with 3 variables.